All right, suppose a teacher that has 5 books only wishes to place 3 of them on the shelf. And how many ways can this be done? So if you want to place all 5 books, that's just 5 factorial. But if you only want to do 3 books, you kind of start this factorial and then you stop before you're done. And so, for this number, it's easy enough to do. We can do 5 times 4 times 3. We could do that by hand. That's a 60. But in general, if we wanted to do this, you'll notice if we wanted to think about how to use factorials here, this would be 5 times 4 times 3 times 2 times 1. That's 5 factorial. But we kind of went too far. We did the 2 times 1. So to get rid of the 2 times 1, notice that this stuff, everything after the 3, is a factorial in and of itself. So if I was to divide by that factorial, this would be 5 factorial divided by 2 factorial. 120 divided by 2, which is 60. So in general, this is the way that we're about to see a formula down here. You'll notice this formula right here, n factorial over n minus r factorial. This is essentially doing this sort of a pattern. I'm using this for what's called a permutation. So we have n items. Maybe you have 20 books. If you want to arrange 10 of those 20 books, then what you'd want to be doing is you would want to be permuting 10 of the 20. And we would write that as P 20, 10. So we're starting, we have 10 books, or we have 20 books total, and we're wanting to permute, we're wanting to arrange 10 of them. This would be P 20, 10. Be careful not to confuse this capital P notation with probabilities. It's a little unfortunate that we use capital P for both of these things, but we never really saw commas when we were talking about probabilities. So that's kind of the only way you can, that's the way you can tell these apart. Another way that these are done is NPR. So on your calculator, you'll see NPR, and if you haven't seen that other video, I'll describe how to get these permutations on that other video as well. All right, so the general way, if we were calculating these things by hand, we would do this n factorial over n minus r factorial, and that gives us this cancellation that I described up there. In this instance, if we had 20 books and we were permuting 10 of them, we do 20 times 19 times 18 times 17 times 15 times whatever. At some point, we get to the 10 times ... Well, that's really just a 10 factorial there. And dividing by the 10 factorial just allows us to cancel that. So we get 20 times all the way down to times 11. So actually with the last one we end up with there. And if you were to count these up, we would notice we would have exactly 10 books that are arranged. So that's, like I said, that's where this formula is coming from. But we're not really going to be doing these by hand. I'm mostly just going to be plugging stuff into the calculator. If you need to read through how to do the steps on your calculator, I have that here. But like I said, there's another video for that. So let's look at some useful permutations. If I have 10 books and I want to arrange 0 of them, the number of ways I can do that. Well, if I'm not arranging anything, there's only really one way to do that. If I wanted to calculate this using this formula, I could do that. You can see n factorial over n minus 0 factorial. This is n factorial over n factorial, which is 1. I'm going to use these to kind of justify why these numbers come up. But also, like I said, if you have 20 books and you wanted to arrange 0 of them, there's only one way to do that. You just don't arrange any of them. You leave them where they're at. If you have n books and you want to arrange 1 of them, this is kind of a silly question because you're not really arranging if you're only picking 1 book. But if you have 20 books and you want to pick 1 of them, well, the number of ways you can do that, you just pick a book. There's 20 ways to do that. In general, with n permute 1, that's just going to be n. And I could look at this sort of reasoning over here, n factorial over n minus 1 factorial. Well, n factorial is n times n minus 1 factorial. And those cancel out. So that's why we end up with just an n there. All right, if we have 20 books and we want to arrange all 20 of them, this is exactly that factorial that we started with. You'd have 20 choices for the first, 19 for the second, all the way down through times 2 times 1. You'd have to do that for all of them. So this would just be n factorial. So I say these are useful permutations because it can be kind of cumbersome plugging these things into your calculator. you're going to be doing it a lot. And if you can recognize some of these where you don't have to plug as much into your calculator, it can speed things up.